I'm going to take this opportunity to refresh your memory on some of the things we went over in class about how we measure things, what properties of matter that we might be interested in, and what units we use to measure those properties. Now in chemistry, I don't think it would come as a big surprise to you that frequently some of the properties of matter that we're particularly interested in are things like mass, or things like temperature, time, volume. And of course, in order to measure something, we need both a number, as you see here, 17, and a unit, as you see here, seconds. Now, for a beginning student of chemistry, it's often tempting to drop the unit. Please do your professor a favor and do not drop your units, because this is a really important thing to retain. It will help you solve problems effectively, and it will help me stay sane. So please write them down. Units, 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 they're incredibly important. In this course, we're going to be primarily concerned with the metric system, which ultimately evolved into the SI, or System International. And we must understand that this is the system that is used in most of the world and everywhere by scientists. So we can use the measurements that were established by the metric system to measure properties of matter such as length, volume, mass, temperature, and time. And we'll notice that very specific units are used. In other words, in order to measure length, we're going to use the meter. Or to measure volume, we're going to use the liter, or cubic meter, and so on and so forth. Now, the System International is really an extension of the metric system. And in order to understand the metric system a little better, I think it's quite instructive to understand a little bit about how it was developed. So in order to do that, we're going to zoom back in time for a moment. In fact, we're going to take a trip to France. Put on your seatbelts. It is 1789. This is shortly after the French Revolution, a very bloody but powerful event in history. After the revolution, a political body called the French National Assembly was formed, which in turn directed an organization called the French National Academy of Sciences to finalize and implement the metric system. So this was a period in history where there was enormous social and political upheaval, and there was also a great deal of exciting developments, I would say, in intellectual and scientific work. Things were being discovered almost on a daily basis about the laws of nature, and it was in fact referred to as the Age of Enlightenment. The 18th century was the Age of Enlightenment, and the metric system is very much a product of these developments. It also reflects some of the politics of the time, because in fact the motto of the metric system was established to be for all people, for all time. Well, that has absolutely turned out to be true. Once it took hold, it really took off. Now, one thing we don't frequently think about when we're learning the metric system is, how were these units established? What is a meter? What is it based on? Well, it happens to be based on something very specific. And I think it's quite interesting to know what that is. So actually, it is defined by, surprisingly, I think, the speed of light. So today, 1 meter is defined as the distance traveled by light in a vacuum in a tiny fractional amount of time. To be specific, it's about 1/300 millionth of a second, but we need to be even more specific than that because these units are designed to be highly accurate. So in fact, the meter is the distance traveled by light in a vacuum in 1/299,792,458 seconds. If we were to delve into these other units a little bit, we would see that there is also a very accurate way of determining what, for example, is a kilogram. This is not really the time to be going into all of this, but I very much encourage you to go on the internet and look at the history of the metric system, understand a little bit more about how these units were developed, because it is utterly fascinating. One note, you don't really need to know that, for example, the gram is the standard unit for the metric system and the kilogram is the standard unit for the SI system. You need to understand all of these units, but you don't really need to distinguish between metric and SI. Going forward, I'm just going to say metric system. I think it's more familiar to us than saying SI. In order to tackle the metric system and conversions in general, we need to realize that we're going to be using something called equalities in order to convert between one unit and another. So there are three possibilities here. We could convert within the metric system itself, we could convert within the US system itself, or we could convert between metric and US systems. In order to do so, we need this thing called the equality. And a perfect example here is the fact that 1 kilometer equals 1,000 meters. Now you can certainly educate yourself on these various equalities. There's nothing terribly complicated here. You probably might want to notice, however, that in the metric system, we are typically dealing in multiples of 10. This is actually very useful and makes it a lot easier to work with. The US, on the other hand, is rather more confusing. There isn't really a rhyme or reason between 1 foot equaling 12 inches and 1 yard equaling 3 feet. Nonetheless, we're living in the US, so we need to understand it, and we need to know how to convert between something like, well, let's say kilometers and miles. So we'll be working with all of these, but our focus is going to be primarily on the metric system. In order to get at the metric system and to understand it well, we have to understand something called prefixes and how prefixes make units get very small. What do I mean by that? Well, if we look at deci, for example, deci means that a deciliter, for example, is 0.1 liters. Or a deciliter, we could say, is equal to 10 to the negative 1 liters. Another way of putting that is a deciliter is equal to 1/10 of a liter. So we have options here. 0.1 liters, 1/10 of a liter, 10 to the negative 1 liters. It all means the same thing. We're just writing it in a different mathematical term. I encourage you to use the scientific notation. It's what we're going to be using throughout this course, and you should be getting used to it and knowing how to work with it. Now, notice that the prefix is a standalone thing, and we could apply deci not just to liters, but to meters, or to grams, or to seconds, and it would do exactly the same thing. A decisecond, for example, is 1/10 of a second, or 10 to the negative 1 seconds. Now, as we go on down the line, the next thing we hit is centi. So same principle, except the centi makes the unit even smaller. A centimeter is 0.01 meters, or, if you prefer, 1/100th of a meter. The best way to say that, of course, is 1 centimeter equals 10 to the negative 2 meters. Now we want to point something out here. If 1 centimeter equals 10 to the negative 2 meters, it follows that 1 meter equals 100 or 10 to the 2 centimeters. So you're responsible for knowing all of these prefixes. And notice as we go on down the line here, the unit gets increasingly small. By the time we get to femto, we have gotten to something rather infinitesimally small. A femtosecond is 10 to the negative 15 seconds. It's even impossible to say that as a fraction, right? And if we had to write it out with all these zeros, well, that would quickly become a hassle. So this is yet another argument for using the scientific notation. I want to point out one other thing, which is notice as we go from deci to centi to milli, we're reducing the size of the unit by a factor of 10. But then as we go from milli to micro to pico to femto, we're actually decreasing the size of the unit by a factor of 10 to the third. In other words, if a millisecond is 1/1000th of a second, or 10 to the negative third seconds, then a microsecond is 1/1,000,000th of a second, or 10 to the negative 6 seconds. I want to explain in a little more detail this back and forth thing that I mentioned. In other words, I said 1 deciliter equals 10 to the negative 1 liters. 1 liter equals 10 deciliters. Let's think about this a little more closely. Here we say, here it's written in this first bullet point that 100 centimeters is 1 meter. Well, that's a way of saying, another way of saying 1 meter equals 10 to the 2 centimeters. Notice what happens if we go the other way around. A centimeter, a single centimeter, 1 centimeter is 1/100th of a meter. Well, that's simply a way of saying 1 centimeter equals 10 to the negative 2 meters. Notice what's going on here. When we go from a large unit to a small unit, so we have a single meter, 1 meter, that's equal to 10 to the 2 centimeters. So we're going from a single large unit, and we're trying to put that in terms of the smaller unit. And then in the second case, we're taking 1 centimeter, a single centimeter, and we're trying to express that in terms of meters. That's giving us 10 to the negative 2. The exponent is the same, the 2 is the same, but we should notice that the sign changes. So you should be fully conversant with this back and forth relationship and get used to doing that with all these prefixes, whether it be milli, micro, nano, pico, etc. You must know all of these. Wouldn't hurt you if you had a little Latin, but it's certainly not necessary. You can get to know them quite easily without. Now we also have prefixes that make our units get giant. I'm not going to spend a lot of time on this because the principle is exactly the same. If we have a prefix like kilo, instead of decreasing the size of the unit, it's going to increase the size of the unit. So in other words, 1 kilometer equals 10 to the third meters. That means that if 1 kilometer equals 10 to the third meters, 1 meter equals 10 to the negative third kilometers. Same idea as what we just saw, except in this case, the kilo is actually taking the standard unit and establishing a larger unit. Again, you need to get to know these units, mega, giga, tera, peta. I would say in particular, I want you to know mega and kilo. It helps with this exercise of going back and forth between small units and large units, or large units and small units, to visualize. So we're going to turn our attention here for a moment to a measure of volume. Here we have a graduated cylinder, and notice that it's 1,000 milliliters. So I think it's very possible you know at this point that 1,000 milliliters is equal to 1 liter. Now, let's say we wanted to express a milliliter in terms of, well, that equals how many liters? Well, one thing that could help us is to see that a single milliliter is actually a tiny fraction of a liter. So that follows that 1 milliliter is going to have to be equal to something smaller in terms of the liter. And in fact, it is, what is it? It is 10 to the negative third. Stylus is being a little stubborn here. 10 to the negative third liters. So, that's a really good exercise to think of it that way. If you're trying to get from a milliliter to a liter, or a microgram to a gram, do a little visualization exercise, and I promise it could help you. Now, since we're talking about volume, I want to just take a quick look here at volumes of different kinds. One thing that we're going to have to get used to in this course is thinking in 3 dimensions. So we have, just to like kind of get the wheels turning here, I want to point out that we have the volume of a cylinder, which is equal to pi r squared h. We're really going to make use of the cube shortly, and the volume of the cube and how that could help us convert between something like a centimeter cubed and a meter cubed. So I want you to make a mental note of the fact that a cube, by definition, the volume of a cube is length times width times height. We're going to be using that. Since we're on the subject of volume, I thought I'd bring it up now, but we'll address it in more detail later on here in this lecture. So here is a good summary of units. You especially need to know the ones here in red. You will be tested on them. You will be using them to work problems. It will benefit you enormously to get to know these. So it's a nice summary. Take advantage of it.